So, you know, I'm not going to try to say it's a total art, but in the beginning in particular, um, they didn't have that much data, they didn't have that many results, so they could just look at it and just kind of assign it. Now we have like tens of millions, hundreds of millions of haplogroups, in the world. And so we have this original scaffold of classification, and people are fitting it into it. And when you see like the new updated labels of these personal genomic companies like ISOG, they have it. It's because we have like so many different branches and how you assign the branches. They wanted to make it more systematic, right? So like my haplogroup is like, I think in theory it's like R1A1A blah 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 blah. Like what's all? Why is it so long? Because it's defining all of the mutational steps.
Okay. This question is number two. Are there any genetic papers positing a mass migration of the E1B1A out of the Levant in Western Asia and into West Africa? That's the first part of the question. And the second part is E1B1A indigenous to Western Asia?
Yeah. I saw this. Like I've seen some of these. These are actually like pretty deep questions in terms of like I think they will be answered. So if there's one issue is tropical areas in general, we have not that much ancient DNA, and then also there's some political reasons. So for example, there's not that much ancient DNA out of Iraq. That's not because it's not dry and it's good. You know what I'm saying? There's not that much ancient DNA out of Iraq because like we messed up Iraq. And like researchers don't want to go into Iraq and get kidnapped or something, right? So there's like political issues going on there. In Africa, like in a lot of tropical Asia, when it's wet and it's humid, DNA degrades, so it gets harder. David Wright's lab, I know they have some stuff that's coming out, delayed by COVID. They've gotten stuff out of caves in Cameroon here and there, but we have a lot of data in Europe because it's cold and some parts of it were dry, especially the north during the Ice Age. We have not that much data out of West Asia, but we got some, and we have very little out of Africa, tropical Asia, right? And so some of these questions that you're asking, I can't give a really good answer because we don't have enough data. What I will say is there are connections between Africa and West Africa and Eurasia, Southwest Eurasia in particular, Mediterranean, West Asia, that people are just exploring. So initially, people used to think, well, Africa is the homeland of modern humans, and you use them as an outgroup, and you look at Neanderthal admixture and blah blah blah, using Africans as zero, right? Well, it turns out the Yoruba, who are the original African population that geneticists often use from the HapMap and 1,000 genomes, have a little bit of Neanderthal ancestry. Where that come from? I mean, almost certainly that's due to what we call Eurasian back migration. We call it back migration because the original pulse was out of Africa. But some Eurasians, almost certainly from West Eurasia, because you can tell that Africans look a little bit more like West Eurasians than they do, like say Chinese. Okay, so they
Right.
didn't come all the way from China. They came from where you would expect, probably the Middle East. They went into Africa. Like when did they go into Africa? Some of it we know is relatively recent. So R1B V88, that's in Chad. Spent
Cameroon, right.
on that part, working on that paper. That's clearly a Holocene. So it's within the last 12,000 years, probably with like pastoralists or something like that. And there's low levels of so the Y chromosome is high frequency, so the paternal lineage is preserved. But overall, they're pretty African. But now they have been able to detect appreciable levels of Eurasian ancestry, and that ancestry is higher in the groups that have more R1B. Okay, so we know that there was recent back migration. We know that for sure. But a lot of researchers think that there was a connections and back migrations pretty deep in the Pleistocene, pretty deep in the Ice Age, say like 15, 20, 30,000 years ago, right? And so when you say, so when you're asking about questions about E1, like haplogroup E in particular, I'm very, very fuzzy and non-committal. There are E's that are found in the Natufians 10,000 years ago, right? So we know that it was in the Near East a long time ago. But we don't have enough data from Africa to say that, so here's a scenario, and this is not necessarily a scenario I believe, but it's a plausible scenario. You could have E1, the ancestor, say in the southern Sahara. It goes north at the end of the Ice Age, and then it diversifies with the agriculturalists, and then it comes back with some agriculturalists. So, like, how do I answer the question in that case, right? Because like we are positing from Spencer's original work, like geneticists used to think that you have the stepwise migration out of Africa and you never look back, but that's not true at all. Like there's a lot of back migration in Africa. There's a few populations that have been only minimally impacted by West Eurasian ancestry, but that's really low in terms of the numbers. So the Mabuti pygmies, like Eastern pygmies in the Congo, and then maybe the Hadza, but even like Khoisan Bushman people in South Africa, they have Cushitic ancestry, and that Cushitic ancestry has West Asian ancestry within it, right? So it's hard to separate these different groups. Um, and so, like, I mean, you're asking about, like, in the questions, like, you're asking about these haplogroups that are found today in certain areas, and with some of them, I can like give you a good answer, mostly because ancient DNA is pretty clear and they're recent. But E1B, it seems pretty ancient in West Asia, but that doesn't necessarily mean that it's not ancient in Africa because we don't have the data, and it's at such high frequency in Africa, as you guys know. Like most, I mean, African hunter-gatherers have the other haplogroups, right? But African agriculturalists tend to be E. It could be a matter of what happened in Chad, where R1B, where there was like a small group of males whose lineages were really high status and they got diluted over time. And we've seen this in other areas. Recent paper out of Orkneys in Northern Europe, which shows Neolithic Y chromosomes, even though the rest of the genome was totally erased, with women coming in every generation from the continent, right? So you can imagine that's one scenario that you can posit, or you could imagine that the whole trans-Saharan zone was a contact zone, and that contact zone gave rise to multiple E branches. That's also plausible. I don't have a strong opinion about where the Semitic languages and stuff come from, or Afro-Asiatic, because I've talked to people, um, and nobody knows for sure at this point. It's very unclear. So that's a
All right.
non-answer question, but that's the truth, I think, at this point.
All right, cool. So, but for sure, for the second part of the question, is E1B1A indigenous to Western Asia?
It it was there. It was there at the end of the last ice age.
Okay.
Because we haven't.
One thing I gotta ask you while in your response. Um, you said around the Natufian time period, we're still on what, 12,000 years ago, around
Yeah,
that time
yeah,
period.
right at the beginning of agriculture.
How do we how does a geneticist or a scientist go about dating the DNA? What's the process of that?
So
In your shortest answer ever, because I know it's a very complicated
no,
question.
dating the DNA is usually they have they have artifacts that like if someone's buried, they're buried with artifacts, so they have like good dates already. So you can date it with artifacts with radiocarbon. You can do it with dendrochronology if there's tree rings around. There's other primitive techniques. Also, one thing with the DNA is a lot of times they're not actually modern haplogroups. You can actually tell that they're basal to the modern haplogroups, and you can define them on the phylogenetic tree and use a mutation rate. That's actually not the best in my opinion, but it gives a rough sense, and it usually correlates well with the radiocarbon.